Run through the review sheet that you have right here. Uh, so, in this recent news story, the mean credit card balance among families was claimed to be uh, greater than $2,600. So here we go, mean credit card bill. So it's either a Z or T test. Keep reading. You do some research, find a random sample of 6 card holders with this mean and that standard deviation. There's no population standard deviation, so this is a T test. Go ahead and write down your degrees of freedom. That's 5, n minus 1. So the null hypothesis. We're talking about means. The claim is greater than. So greater than always goes with the alternative. And so since we did greater than, um, we really could pick equals, less than or equal to. I'll go less than or equal to $2,600. I'll throw the dollar sign in just so there's a little bit of context. So now check conditions. Is it random? And it was. That's given. And then n is not greater than 30, so we're just going to have to assume that this thing is normal. And so we have a small sample size, so we need to make sure that this thing is normal. All right. Now it's a matter of just go to the calculator, plug this stuff in, and when all is said and done, so t equals, so the observed x bar was $2,528. The predicted should have been 2,600. The standard deviation for us is 325, and we go over the square root of n. All that stuff is equal to negative 0.54. I have a p-value that equals 0.69, which tells me at an alpha level 0.05, right? 0.69 is greater than 0.05, so you're going to fail to reject the null. Oh, excuse me, they gave us a different alpha level. Let me fix that real quick. They actually gave us an alpha of 0.10. I just realized that. Still greater than, our p-value is still greater than that, so fail to reject. So evidence suggests um, the average credit card balance is um, hmm, oh, I turned that around backwards up here. Apologies, it's kind of hard to see that with the dollar sign, but is at least 2,600. If you put equals up there earlier, it should say 2,600. Um, part B, just construct a 90% confidence interval. So this would just be a T interval. A lot of it's going to be very, very similar. Degrees of freedom, again, 5. Conditions, same as above. So I'm just going to put C above. Um, no need to write, there's no hypotheses with an interval. We just need to write uh, uh, the formula, fill in the formula. So we have x bar 25, 28 plus or minus 90%. Uh, since it's a t interval with 90%, we'll come back to that value here in just a minute to get that t star. And remember, we have just sigma over square root of n. So sigma for us was 325 over the square root of 6. So that t star, right, this is just a good reminder. We need the t star for 90% confident level, 5 degrees of freedom. So if you go to your chart, 90% confidence, 5 degrees of freedom, is 2.015. And I'm going to let the calculator take it from there. And what that kicks back to me, 2,260 to 2,795.4. So I'm 90% confident the true mean credit card debt is between $2,260.60 and $2,794.40. What that tells me, that the $2,600 or the claim of, appears true because it's within the interval. All right, so there's your step back to last unit. Describe a type 1 error in this scenario. So type 1 would reject the null when it is true. So our null was greater than or equal to. So what we would claim, you'd claim credit card debt is less than 2,600 when it is at least 2,600. Again, this is the way that I have it set up. If you have equals above, then you'd put, instead of at least, it is 2,600. All right. If the probability of type 1 test is 0.5 and the probability of a type 2 is 0.3, what's the power of this test? Remember, power equals 1 minus beta. So for us, our power is 1 minus 0.3. So this has a power of 0.7. Next page, a researcher claims 24% of adults are afraid to fly. Going to test this claim, so you do this random sample. Here we have a one prop z-test. So we'll go ahead and set up, there's HO, there's HA, we have P's here. He claims that 24% are afraid to fly, so 0.25. There's no claim, you just want to test the claim, you don't think it's higher, you don't think it's less, so we're just going to test the claim and it's not 24%. Conditions here for us, is it random? That's given. We need more than 1,000 or 10,750 adults, and then we need 1,075. We're going to put P here because this is a test, and we're going to put Q 0.76. Both those are greater than or equal to 10. So here it's a z-test, which means our test statistic is z. We're going to let the calculator do the work for us. We're given an alpha level of 0.05. And now just plug and chug into the calculator. And we end up with a z-score of 2.428. A p-value is 0.015. So 0.015 is definitely less than 0.05. So we will reject the null. And so what that tells us is that it appears that the proportion of adults afraid to fly is not 0.24. All right. So researcher appears to be incorrect. Alrighty, and now just go back in and fill in that z-score very quickly. So the observed, the p-hat was 0.27, the predicted was 0.24, and then standard deviation, remember you use p here, so 0.24, 0.76 over 1,075. So describe a type 2 error when we fail to reject the null. So we would claim the proportion of adults in U.S. afraid to fly is 0.24 when it is not. What's the probability that we make a type 1 error? So in this particular case, they told us, hey, alpha is 0.05. Construct a 95% interval. So again, what you could do here, just go ahead and pause the video for just a moment. I'm not going to walk through it, and if you'll hit pause, I'll put the answers up in just a second. So hit pause. Seriously, hit pause. Go hit pause. So here's where we are. The one prop z interval. I will point this out before I go to my conclusion. Remember, you're going to use p hat both here and in your standard deviation because this is an interval. All right, so we use p for the test, p hat for the interval. So here we go. We're 95% confident the true proportion of U.S. adults afraid to fly is between 0.245 and 0.298. Researcher here appears to be incorrect again because 0.24 is not on the interval. All right. So one last problem down here for us. So a recent survey indicated 19% of employees are concerned about losing their job. So the politician is going to use this information to focus on employee issues. He doubts 19%, does his own survey, random sample of 1,000 employees in a manufacturing job, indicated 213, and 5%. Does this result help or hurt the politician's doubt? So he just doubts the 19%. So real quick, just so we can set up our test right, this is a one prop z-test. It looks like the claim is that it is 19%, and he doubts it. So 0.19. I know we've seen that problem already. So now just this problem, just run your test very, very quickly. You don't have to worry about doing all the little steps in between. Just 3.22, a p-value 0.001 at any reasonable alpha level. That's well below any reasonable alpha level, so you'd reject the